Good afternoon. Today we are going to present about the statistical databases. A statistical database is a database used for statistical analysis purposes. Statistics may be performed to compute aggregate functions such as sum, mean, median, and more. Statistical databases deal with multidimensional datasets. The example shows 2D representation of statistical data where the summary measure is GDP, function is sum, dimensions are country, continent, and year, and classification hierarchy is as shown. Types of statistical databases. In an online statistical database, there is direct real-time interaction of a user with the data through a terminal. In an offline statistical database, the user neither is in control of data processing nor knows when his or her data request is processed. In this mode, protection methods that keep track of user profiles become more cumbersome. Static statistical databases. A static database is one that never changes after it has been created. Most census databases are static. Whenever a newer version of the database is created, that newer version is considered to be another static database. In contrast, dynamic databases can change continuously. The feature can complicate the security problem considerably, as frequent releases of new versions may enable snoopers to make use of the differences among the versions. Data perturbation methods. They may not be suitable for dynamic statistical databases since the effort of transforming the original statistical database to the perturbed one may become prohibitive. In a centralized statistical database, there is one database. In a decentralized distributed statistical database, overlapping subsets of the database are stored at different sites that are connected by a communication network. The security problem of a distributed statistical database is more complex than that of a centralized one due to the need to duplicate at each site the security control overhead as well as the difficulty of integrating user profiles. Areas of application comprise mostly of socio-economic databases and occasionally research databases. Census data are collected to access trends of population. One of the most crucial issues in such data is the representation of multi-level geographic classification hierarchy. This hierarchy can be very voluminous. In the US, census data is collected on individuals and summarized to the block level. Economic data. This type of database contains statistics of sales and income of industries, or consumptions and productions of various products such as crude oil. Statistical databases are also used in medical and academic field by researchers and scholars.
Statistical database security. Statistical databases may contain confidential data on individuals, but users are permitted to retrieve statistical information on the population. Inference problem occurs when a person deduces confidential data by correlating declassified statistical summaries and prior information. Compromise occurs when a questionnaire deduces from responses of one or more queries confidential information about individual record. Statistical database security techniques aims at preventing retrieval of individual data. This example is a simple illustration on how sensitive data can be compromised in the absence of statistical database security measures. Suppose we know that Elizabeth James is the only female that has a PhD degree and lives in Rome, New York. The query below will return her salary. We now discuss various security methods for statistical database protection. Query set restriction. A query set size control limits the number of records that must be contained in a result set. The query results will be displayed if and only if the value of result query lies between K and L as shown in the presentation. In the example to the left, we see that the value of K set by the database administrator is greater than the query result, and so the query results are not displayed. Query result is displayed only when the size of the query is greater than K set by administrator. Micro-aggregation. Individual data is grouped into aggregates and average value of the group replaces the individual values. Data with most similarities are grouped together to maintain data accuracy. This helps to prevent disclosure of individual data. Some examples of this technique are median household income census released by government is at state level. Household income is averaged together to maintain purity but still provides protection against disclosure. National Agricultural Statistical Service also uses microaggregation technique to publish data on farms. Data perturbation. Perturbed data is raw data with noise added. The advantage of this technique is that with perturbed database, if unauthorized data is accessed, the true value is not disclosed. However, data perturbation runs the risk of presenting biased data. Output perturbation. In this technique, noise is added to the output of the query. The bias problem is less severe than in data perturbation technique. Auditing. Auditing is the process of keeping track of all queries made by the user. It is usually done with up-to-date logs. Each time a user issues a query, the log is checked to see if the user is querying the database maliciously. In this slide, we compare the various statistical database security techniques we have learned so far. It can be seen that data perturbation results in the highest level of security and also richness of information, which represents the amount of non-confidential information eliminated, which is high to moderate. On the other hand, query set size control is low on all fronts. We now talk about some of the disclosure avoidance techniques used by the US Census Bureau. Noise infusion. Sometimes noise is added to demographic survey variables when other more traditional protection methods are not suitable. For example, noise is added to the age variable for persons in households with 10 or more people. Categorical thresholds. All categorical variables must have at least 10,000 people nationwide in each published category. Any categories not meeting this threshold must be recoded into broader intervals. Top coding. Top coding is used to reduce the risk of identification by masking outliers in continuous variables. For example, someone with an income of $5 million would appear to have a much lower income in the public dataset. All continuous variables such as age, income, etc. are top coded using 0.5% or 3% rule. Data swapping. In data swapping, we identify special uniques, which are household record unique based on certain demographic variables at high level of geography and thus have substantial disclosure risk. Each such household is targeted to be swapped with another household in a geographic region. Swapping typically does not affect many records. These are some of the references that we have used to create our presentation. We now come to the end of this presentation. Thank you for watching this video.